In this lesson, we're going to go over Venn diagrams. Specifically, we'll identify the certain types of Venn diagrams, we'll describe regions of Venn diagrams, and we'll also use Venn diagrams to display categorical propositions or statements that we can make from the Venn diagram. So a few terms to know for this lesson. We have sets, Venn diagrams, and categorical propositions. Sets are a set of collection of objects called members. Sets are written with braces. So if we have the set of days that end in Y, we have the braces, and then we have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday with the closed braces. Now with this set, you could have written the days that end in Y in any order, and then just making sure that they're denoted by a brace on the left and a brace on the right. The days, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday would be the members of this set. A Venn diagram is a way to visualize relationships between sets, and categorical propositions are a claim about a relationship between the sets. So in the next set of examples, we'll go over the types of Venn diagrams you'll see, the sets that are contained within them, and then statements we could make from the picture. So the first type of Venn diagram that we'll go over is the subset Venn diagram. So the definition, when you have a subset Venn diagram, one set is entirely contained within another, which means that all members of one set are also members of another. So for instance, with this picture on the right-hand side, the set of whales is entirely contained within the set of mammals, which means that all whales are mammals. So all whales are in this set of whales, and it's entirely contained within this set of mammals. Okay. So another way to say this is the set of whales is a subset of the set of mammals, and then the categorical proposition here is all whales, the entire set is contained within the set of mammals. Okay, so let's talk about the different regions of this Venn diagram. So within the set of whales, we have all different types of whales. Within the circle of mammals, anything in this part here that I'm coloring in blue would be mammals that are not whales, so humans, for instance. And then anything outside of the circle of mammals would be something that's not a mammal, like a reptile. The next type of Venn diagram that we'll talk about is a disjoint Venn diagram. So when two sets are just disjoint, that means that they have no members in common or no things in common there. So if you look on the right-hand side, we have the set of fish within the circle of fish and the set of mammals, and there's no overlap. The circles don't touch each other. One's not within the other because they're just joint. They have no members in common, which means that no fish are mammals, no mammals are fish. Okay, and another way to say this is the set of fish are disjoint from the set of mammals. Okay. So we have our set of fish in one circle, we have our set of mammals in the other, and outside of those would be animals or whatever our overarching category is. Probably, oops, let me erase it. This would be not fish or mammals. So things like snakes would be in this, outside of those two circles. The third type is an overlapping Venn diagram. So as you can see from the picture to the right, we've got two sets and there is some overlap. So what that means is that there's some elements or some members that are in both sets. Okay, or another way of saying that is some members are shared or in common between the two sets. So what we can say is the set of doctors and women is overlapping, which means that in this overlap, they meet both conditions. So women doctors would be this purple section. Okay, in this region here, this would be doctors that are not women. Let me change colors. In this region here, this would be women that are not doctors. And when I say this region, I'm talking about just this green part right here. And let me do the same. Because what's in between are women doctors, meaning that some in one set, so some doctors are women or some women are doctors, and you'll see that below in the categorical propositions, a few different ways to describe that. And then outside of the set, let me pick a different color again. This would be people who are not women and not doctors. Okay, so after those examples, now we can translate this into some math. Before we get to that point, we'll describe the regions of the Venn diagram. So for instance, in this Venn diagram, we're talking about people at a party. We have two sets, people that eat ice cream and people that eat cake. The sets are overlapping because there are some members that are going to be in common. Okay, and so using these, the letters on the Venn diagram with what's below, we're going to describe the regions that are here. So region A is people that eat only ice cream. And now region A is just this part right here. Okay. Region B is people that eat only cake. Region C are people that eat cake and ice cream. I have a sweet tooth, so that would be me. Region D, so anything that's outside of those circles but still within the box of people at a party, are people who don't eat cake or ice cream. Oops. Okay, so you don't necessarily have to draw all over the Venn diagram like I do. I'm emphasizing that to show the different regions that are there, but really breaking it down piece by piece can help, and it'll translate into the next section too when we analyze arguments using Venn diagrams. Example number 2, this is where we'll do some calculations. So this entire box that you see on the screen represents people at a conference, and what we'll do is we'll use this to answer the questions below. So let me zoom in on this a little bit so you can get a good picture of it. Okay. And so in this case, we have 3 sets and they're all overlapping. So there's some regions that are only in 2 of the sets, and there's at least one region that members of all 3 sets that we see here. Okay. Oops. Okay, so question number 1, how many people at the conference are unemployed college graduates? So we want people that are overlapping because we have, let me do this in blue, unemployed college graduates. So we have our set of college graduates, we have our set of people at the party who are unemployed, and this overlap is what we're talking about here. Okay, now since this problem didn't say who are not women, we include the 5 as well. So this would be 5 plus 7, which gives us 12. For question 2, how many people at the conference are employed women who are not college graduates? So employed means anything outside of the circle of employment. So I'm tracing it with my pen. Okay, so anything outside of this circle. We want who are not college graduates, so that excludes this set. So we've got 2 sets excluded. Are employed women who are not college graduates. So we're just looking at this 19. Okay, employed women who are not college graduates. So they can't be in the circle of college graduates at all. There can't be any overlap there, and there can't be any overlap with the unemployed circle because we're talking about employed women. Number 3, how many people at the conference are employed women with a college degree? Okay, so with this one, let me erase the previous. So again, we can't have anything in the circle of unemployed because we are just looking at employed women with a college degree. So we're looking outside, and since we're looking at the overlap women with a college degree, we would be looking at this 8. Oops, I wrote it in the wrong spot. 18. Okay. And then question number 4, how many men are at the conference? So let me erase again this pink writing and change color here. Okay. When it's asking how many men are at the conference, that means anything that's outside of the circle of women. So here's our circle of the set of women. So we would be adding up anything outside of that circle. Okay, so this would be 24 plus 6 plus 7 plus 11, which gives us 48. Okay, and again, this 6, what it denotes is members that are not part of any set. So not women, not college graduates, not unemployed. Thank you for watching. If you have any questions, please feel free to reach out to me.